hear me, yeah?
Yes, Doctor.
Is it okay? Okay, I will share the file.
Yeah.
So let me share and see how is it. But no, I think cannot. I have to do to take the record first. Then I will share the file. Okay. So can you see the screen? Can you see
No,
the
Doctor.
screen?
Yeah.
You cannot see the
Now can.
Yes. Okay. So just let me ask you your progress. So I think I have given you the perturbation method for quite a long time, right? So so far how far you can go? You just take note first and then you decide to do it during the holiday, right? Okay, so I think so far so good, nah? But I think just now I refer back to this paper, the paper that I sent to you. So I look at the end. Okay, at the end of this paper, I think you have it. Okay, so there is a part here. Okay, it must be stressed that the standard procedures of nonlinear optics, the standard procedures is what I have go through from the beginning of the semester. I mean the expansion P equals to P1 plus P2 plus P3 and so on, which result in power series expansion in terms of the electric fields cannot be used to describe this type of bistability. Okay, the potentially important class of bistable interaction, which result from intrinsic material bistability must be treated by procedures similar to the one outlined above. Okay, so the article said that the Duffing oscillator model that he used here cannot use the method. I think he had tried before. I think we better believe him. But so far, if you do not put much time on that, I think it should be okay. Because that kind of power series expansion will help you to understand the concept, how basically how the nonlinearity is generated, and you may get fundamental frequency response. You may get the intensity dependence response that we have derived the chi3. But the chi3, if we done so far according to this statement, means that we cannot use. But it's still alright that we use that to understand the concept. So it seems that it depends on the intensity, intensity dependence. So if like this, we just go back to this article and follow it. We follow this article bulat-bulat. Okay. So I think it should be okay. Let me find the equation. Okay, so we go back to this equation this one we have done it already. We have already put this term into here, so we have done this part also, and then we managed to obtain this part. Okay, so we have done something good, something good enough. Especially the wave equation. Okay, So this kind of power series expansion, so you just leave it like this. It's it can be one part of your discussion of your thesis. Okay, so but the wave equation is very important. We have done our wave equation. We have done our wave equation. So this is I try to simplify it. So it is here. So this is the wave equation that I have shown to you last week. Okay, so we will use this equation. So starting from here, you can take your photo. So this is the wave equation that we are going to use. So let me give you something so that you can do during your holiday. So we follow the paper directly. Okay, so before you do anything, this is the wave equation in terms of E and P. And before you do anything, we have to use one of the Maxwell equations, curl E. So this part is the B, we consider it has the same time dependence as the E field. So if you take the time derivative, you have I omega. So you have minus I omega. Minus minus, you get positive I omega. And then this is the wave that may, okay, this part is the amplitude. This is the curl E. Okay, curl E I expand into the determinant form. It is like this. So when you work it out, you can see that there is no I component. The J component is del E over del Z minus del 0 over del X. So we have this. And then electromagnetic wave is transverse. So you don't have the you don't have the K component. Even though you still have the del EX over del Y, but you cannot let it be there. So you have only the J component. So it's you have this. So we take away the unit vector J. So you have the By equals to this. You just rearrange this term, you put it down over there. So you rearrange, so you get this, the B. So it means that once you get the E from this wave equation, if you solve the E, then you have no problem to solve your B by putting your E into here. Okay, so now we already go back to the beginning of the paper. So this is the beginning of the paper. Okay, so there are constant here. I keep on having problem with the constant. So when you work it out, please be very careful of the constant. But here I just to let you see the conceptual things. I won't go into the details. You need to do it during the holiday. Okay, so I copy paste here. I think it's somewhere. So just a bit different. M over E. This is gamma prime. I think it's correct. Gamma prime. And then this one we work it out. Looks so just to remind you, okay, we have done this part. So the VD we substitute as in the paper. So we take the derivative. We take the derivative. So you get something kappa x plus beta prime x to the power of 3. But in order to change it to P, we multiply with E. So we multiply with E cube divided by E cube. Because that